Good afternoon, everyone, and welcome to the Northeast Clean Freight Corridor webinar series. We're at webinar number 3, Electric-Powered Trucks, Idle Reduction Technology and Infrastructure. My name is Alicia Gildy, and I am the Northeast Regional Director for CALSTART, a national clean transportation organization, and I'm also the chair of the Strategic Planning Committee and the Northeast Clean Freight Corridor Initiative on behalf of the Northeast Diesel Collaborative. I'm also joined here today with Abby Swain from EPA Region 1, and both of us will be working with you to guide today's discussion. So let's go ahead and get started. All right, so what we'd like to do is show you our progress against our Clean Corridor roadmap. Then we'll go ahead and we'll dive into our discussion. We have 4 great panelists today that have really put some good effort and time into their presentation, and certainly with their expertise can give us some perspective on how we can apply electric technologies and infrastructure to our Clean Corridor effort. And then at the very end, following all of everyone's presentations, we'll dive into a really good, meaningful back and forth discussion. So a few things that I want to just bring up just so that everyone knows. What we're going to do, since we do have a number of presentations to go through today, I'm going to kindly ask that everyone, if you have a question or a comment, if you can go ahead and enter that into the question box or the comment box. Abby Swain is going to be keeping track of all your good questions, so at the end, when we do have the work group discussion, we'll make sure that we keep track of all those good questions, and we'll go through them together as a team. The second thing, and Abby mentioned this early on, we do have 2 attachments included to today's webinar. One is the entire presentation for today, so go ahead and feel free to download at your leisure. Secondly, we have a save the date for the Northeast Diesel Collaborative Partners meeting, and we'll talk about that briefly. So please feel free to download those at any time during the webinar. And then lastly, we had put together a number of questions that we would like to have you respond to. It will be a survey that will be activated following today's webinar. You'll also receive an email in case you're not able to respond to it right away. At the end, you'll receive an email that will basically give you an opportunity to fill out the survey at a later time. All right, so this is our 2017 Northeast Clean Freight Corridor Workgroup Roadmap. Last time we had a great webinar talking about the fuels and infrastructure to promote clean freight corridors. We were talking about natural gas, renewable natural gas, biodiesel, and hydrogen, and what that means for the Northeast, looking at current and existing infrastructure, the type of projects and partnerships that are available for us to look at how we can further continue to fill in the infrastructure gap. Today, we turn our attention to the electric-powered trucks, hybrid trucks, idle reduction refrigerated units, and also looking at how do we electrify our infrastructure so that we can promote the adoption of these technologies throughout the Northeast. Our next call will be on August 24th, and that will be looking at priority locations and facility types for truck and intermodal idle reduction and alternative fueling. So do look forward to that discussion. You will note in some of the survey questions that we'll have you reply to at the end of the webinar will be in preparation for our next webinar. So thank you so much for your help with that. And as you see, looking at our roadmap here, it's leading us to our next big meeting in September, which will be at the end of September, September 25th and 26th. Again, we have enclosed the save the date to the webinar so that you can download it. And I do encourage that you do, because the PDF has active links and it can bring you right to registration for the event, as well as information on the hotel. We have a really great program in the works. We'll soon to announce the topics of the agenda for this meeting, but certainly we're going to be talking about emerging technologies, looking at what clean transportation, manufacturing, and the rollout of these technologies means to jobs in the economy. We're going to be talking about funding like VW settlement funds. We're also going to be talking about our Clean Corridor efforts and really bringing all of the great work that we've done this year so far to a head, where we're going to be talking about what's next, how do we work together to promote filling in the infrastructure gap. All right, so today's objectives, what we want to do is just understand the status and opportunity for truck idle reduction and refrigeration technologies, medium to heavy duty hybrid and electric vehicles, and infrastructure in the Northeast. What are the existing and emerging technologies in the forefront? Demonstration, just understand the demonstration of these technologies, where they've been successful, incentive programs that are helping us to move these technologies forward, where there's growth opportunities, and then expanding our infrastructure for transportation electrification. Also, what we want to do as a work group, how do we continue to add value and provide a platform for information sharing and support the regional planning and coordination efforts that we've been promoting all along through our Clean Corridor efforts. We have 4 speakers today, and I will be introducing you to each of them. But just to give you an overview, we have Linda Gaines, Bill Van Amburg, Patrick Bolton, John Shipman, each of them bringing a unique perspective that I think will enlighten you on the technologies, the infrastructure, and the opportunities to reduce emissions while looking at these innovative technologies that will help build out our Clean Corridor network. So let's go ahead and let's start with Linda Gaines. Linda Gaines is a transportation analyst at Argonne National Laboratory. She holds a Bachelor of Arts from Harvard and a Ph.D. in physics from Columbia University. Her primary interest is problem solving, applied to efficient use of resources. Her most recent work has involved studying ways to reduce petroleum use and other impacts from transportation by recycling batteries and by reducing idling. She is an editor of the new journal, Sustainable Materials and Technologies. Linda, welcome. We are so happy to have you.
Thank you very much. Next slide. So basically, any kind of vehicle you can think of is going to idle at some point. Sometimes there's no particularly good reason for it. There just wasn't any great impetus to turn the vehicle off. And so that's why the vehicle is idling. The best advice is just turn it off if it's going to be stopped for more than about 10 seconds. But most vehicles are idling for a reason. They need some kind of service, either heat or air conditioning or lighting or power. Next slide, please. So there's technology that you can use to reduce idling. Many of these are available across vehicle classes, and I'm going to discuss each of them in turn, focusing on the electrification of parking spaces at the end. You can see on the bottom that the capital cost to the truck owner of the different technologies varies, with an APU costing about $10,000 and a little heater $1,000 or perhaps less if it's an electric one. You can also see on the right the operating costs of the different kinds of technologies. Electrified parking spaces are independent. They're on a per hour basis, independent of fuel costs. So you see the operating cost for a truck owner parked at one of those is flat, whereas the ones that are sloping up are functions of the fuel price, with the biggest one being idling, since it uses more fuel than any of the alternatives. So you can see why there's not an incentive for truck drivers to reduce their idling just from the basis of fuel savings. Next. We're in the process of putting together a compendium of available equipment. So it will list all of the different manufacturers and models for the appropriate kinds of technologies. And it also lists what vehicles they're applicable to and what services they provide. Next. So the first type of technology that I'm going to mention is auxiliary power units, which are basically generally a small diesel engine with a generator to supply electricity and heat and air conditioning, and essentially whatever needs the truck driver might need. There are also small APUs that are available for police cars, and these are subject to weight exemptions, so that if you've got a big heavy truck and you want to put an APU on it, you're not going to run over the weight limit. Another important point for the corridors is that many of these can be plugged into a wayside unit, so that even if it's parked somewhere where there's no infrastructure and it'll be running as a diesel, but if it does in fact find some place to plug in, it doesn't need to be burning fuel. Next. You can also get just a dedicated air conditioner, and those can either be battery powered or powered essentially by having a big block of ice in the truck, and the ice is frozen or the battery is charged by using energy that's essentially drained from the truck while it's running down the road. So there's nothing that's on while the truck is stopped. The big drawback with the battery or the cold storage APU air conditioners is that they really tend to only have enough capacity to keep the truck cool for something like 10 hours. And over-the-road trucks have 34-hour restart once a week. And so you need something else to keep the driver cool during that period. There are also swamp coolers or evaporative coolers, which you can use in dry regions, which basically just keep you cool by blowing air over water and cooling the air. There are also air conditioners that you can get for smaller vehicles than long-haul trucks. Next. You can also get just a little heater, which is very inexpensive, does an excellent job. Those are particularly good for trucks that are driving or buses in cold regions where you aren't so worried about air conditioning. There are heaters available that run on alternative fuels so that you don't need to idle your CNG powered truck either. Next. The heaters are very, very low energy users. There are also simple systems that turn the vehicle's engine off, and again, you can get this for any size vehicle. And one important feature of that is that if your vehicle doesn't have one of these idle shut-off timers, which just shuts the engine off, it does not restart it ever, that's the only way you can get credit for under the Phase 2 greenhouse gas rules. There are also automatic shutdown startup systems, and those again are available for all different size vehicles. They're particularly useful for police. In that case, there's a sensor that monitors the battery power, and if the battery gets too low, it'll restart the engine to charge the battery. The problem with that on long-haul trucks is it's noisy when the engine restarts, and it often can wake up the driver. Next. So the next piece of equipment is actually not something that reduces idling itself. Telematics or a GPS system just is an information transfer system. And so it monitors and records where your truck is and how long it's idling and engine function. And in fact, there are all different kinds of vehicle diagnostics that you can get through your GPS. And what this serves to do is just inform the driver and the management as to what idling is indeed happening. And so we've talked to a number of companies where they put in just a simple GPS system, and they determined that the drivers were idling 30, 50, whatever % of the time. And just by knowing this, they were able to reduce their idling significantly. But I'm particularly interested in it because it's just the tip of the connectedness iceberg. And in fact, there are all kinds of improvements that you can make in transportation systems by connecting the vehicles. One obvious one that's been implemented is transponders connecting your car with the toll booth, so you don't have to stop at the toll booth and give them coins. Similarly, there are systems that provide information about the cargo in a truck so that you don't have to waste as much time at border crossings or at way stations. There are also ways that you can make the operation of your fleet way more efficient if you've got information transfer. So this is a big topic that I'm very interested in, and I wanted to mention it. Next. So the main topic of this is electrified parking spaces. The idea of this is you've got a long haul truck and it's driving across the country, and the driver is out of his hours of service and he's got to go to sleep for the night. The practice for years and years was that the driver would just keep the truck idling, and that would supply heat and air conditioning and lighting, and waste huge amounts of fuel, make lots of noise, make emissions, and generally be expensive because fuel is pretty expensive. And so electrified parking spaces were developed to supply all of the services that the driver would need through those yellow tubes that you can see. There is, however, at most of these locations, and there are, I believe, 60 of those across the country right now. There's a map later. There is no place to plug in your reefer, and you can see that that you would need like a long extension cord or something if you were going to. There's no capital equipment for this type of system that's required on board the truck except a very cheap window adapter. The problem is that the utilization of these systems has been rather low. There are in a number of places installations that have gotten significant use, but on the average, the single system, which is the one that requires no onboard equipment, has gotten about 10% usage at its locations. A key thing that probably is important for the corridors is that dedicated terminals have gotten much better usage, partly because it's got essentially a captive audience, and also because you don't, in general, when you have a terminal, you're just parking the tractor and the trailer is elsewhere, and so you don't need as much space for it. Next. Dual system EPS requires equipment on board your truck. So if you've got some electrical equipment on board your truck, this is essentially a plug where you can plug it in. You can also plug in your ETRU at many of the locations. And again, you can power your APU or your heater, air conditioner, microwave, whatever, through this system. Instead of being like $1.85 an hour, which is the single system EPS is, it's more like $1 an hour, so it's cheaper. And there was a big DOE funded project under the stimulus program where approximately 50, I think it was, locations across I-80 and up and down I-5 on the West Coast were electrified, and trucks were given money to help them put equipment on board the trucks. Unfortunately, utilization achieved through this project was very disappointing, with the average only being 0.4%. And there was one location that you'll see on a map in a bit that did achieve 7.7% utilization, but that's still not great. Next. So the electrified parking spaces get used the most in the summer, and that's because they, at least the idle air system, which is really the only viable company that's operating these now, has extremely good air conditioning. And so for places that are very hot, which you'll see in a sec, utilization in the summer is very good. Next. And of course, also utilization is best in the south. That's on the next slide, which shows that the most of the utilization is in the south. The red circles on this are the single system, and the scale is such that the big circles are 20% utilization. So you can see there are a number of locations that have gotten fairly good utilization, remembering that mostly trucks are going to be parking at night, and so 50% utilization would mean that every space was used overnight. So 20% is okay. The blue dots are the shore power, the dual system, and the scale is smaller with that one blue dot up in Oregon being 7.7%. So the utilization has not been what people hoped it would be. Next slide. And what you can see is there are, in fact, you see there's a big red blob on this slide that is really resolved into 5 locations in Pennsylvania and New Jersey that actually do have significant utilization. So the real question is, how do you get one of these used? Why is it used? Next slide. And I'm emphasizing utilization both because you don't save petroleum unless you actually are using the system. And also you can't make money on installing it, and it can't even break even unless you actually have people using it. So I looked at the 2 types of EPS and compared them, and also included terminal installations. And it is very clear that the terminals are the places that are being most successful, and that is where most of the growth in this system, this type of system, is now. Next slide. And there were a number of suggestions made in the final report that Shore Power gave to the Department of Energy as to why the utilization of the system was so poor. I'm not sure that any of them explains it. It's very difficult for me to really understand what's going on here. One certainly is it helps to have coverage, but part of the idea of the whole project was there would be coverage across several corridors, and that didn't seem to solve the problem. So next slide. So we compared the economics of the different types of idling reduction systems for long-haul trucks, and there's a report that you can download. The website for it is on a later slide. And how they compare depends both on the number of hours that the vehicle might be idling and also on the price of fuel. And with the price of fuel as low as it is right now, it really doesn't pay necessarily to put in an idling reduction system of any sort unless you're going to be idling for a large number of hours. So financial necessity is not right now the big driver, but as you I'm sure know, idling is not allowed by regulations in most states or in many states. Next. We also looked at what the payback would be for different types of systems, and as is expected, for low fuel prices and low idling, it takes a long time or perhaps never to pay back your system. If fuel prices go up, these systems do eventually pay back. And if you're idling a lot, they pay back rather quickly, even at low fuel prices. So right now you can see that even the most expensive system would pay back in 4 or 5 years at the current fuel prices. And in case you're wondering why the red line, the single system electrified parking space, looks weird, it pays back essentially instantaneously if an hour at the plug-in unit costs less than the fuel you would have used, and if it costs more than the fuel you would have used, then it never pays back. So it's just a very simple L graph. Next slide. So I wanted to mention that VW settlement funds can be used for idling reduction equipment. They can be used obviously for electrified parking spaces, which, by the way, are not just available for trucks. You can also plug in locomotives and ships, so that's kind of cool. And they can also be used for verified idling reduction equipment. So that's useful information, I think. And of course, you can also use the funds to replace a vehicle or replace the engine. Next. Now, if you want to calculate your own payback for an idling reduction device, we have a calculator that's available on our website, and it's also linked through IdleBox, which has a lot of useful tools for reducing idling. And you can see that the back of this worksheet also includes some estimates of fuel use per hour, which is something that you need to put into the worksheet. Next. I think that's basically all I've got. I wanted to thank Patricia Weikesheimer, who put together the IdleBox and was the editor, or the writer for the National Idling Reduction Network News, which is currently not being published. And I want to thank the Clean Cities program, which has funded all of this work and distributed all the, all the information to the coalitions and through IdleBox. Thank you.
Great. Thank you, Linda. Thank you for the excellent presentation and overview and extremely informative. So thank you very much for your efforts there, and we appreciate all of your expertise on the matter. So thank you. Our next speaker, Bill Van Amburg, who is the Senior Vice President of CALSTART, he's going to be talking about the hybrid and electric truck and bus technologies that are in the marketplace today and what that might mean for us in the Northeast, and certainly looking at emerging technologies coming around the corner and why electric truck transportation is here today. Bill Van Amburg is also the lead of our commercial vehicle activities at CALSTART. Bill has nearly 40 years of experience in technology development, commercialization, and marketing. He personally leads initiatives in fleet sustainability standards, creating national truck and bus incentive programs, and effective fuel economy regulations. He is a graduate of the University of California at Berkeley and the Executive Management Program at UCLA Anderson School of Management. Bill, welcome, and thank you so much for joining us.
Oh, my pleasure to be here, and good afternoon to everybody, and happy to talk about this issue. I think as we're thinking about corridors, I think what we'll find is the electric and hybrid capability is really starting to emerge around the nodes, around the edges of the corridors. But I think, as you'll see from what I'm about to show, it's developing the capability now over the next 5 to 10 years to transition into key segments of the corridors, particularly around the goods movement and the last mile portion of goods movement and our corridors. So let's, Alicia, go ahead and move to the next slide. And just to give people a sense of really what's coming down the pike, what's available now, I pulled together, and don't try to read all the examples, but I wanted to give you a sense of all the different kinds of vehicles that are hybrid, electric, and then even low-NOx natural gas, because good programs should give fleets choices. But what's available in the marketplace today? I think it's pretty exciting. And now what's coming? Let's go to the next slide, and just a couple of quick examples of what's changing in this really dynamic marketplace. First of all, you've heard of Tesla on the car side of the equation. Tesla's announced that they're going to be doing, in essence, a Class 8 tractor. Look for some kinds of announcements in the fall. This is very exciting to have their capability and, if you will, market spark entering the space. Next slide. We also know that some of these capabilities in electric are very scalable, meaning that the core components can be built up into larger powertrains. This is exemplified by what Toyota is testing right now in the port of Los Angeles, which is they took 2 of the fuel cell power units from a Mirai car and are using them to now power a Class 8 drayage truck, meaning a regional cargo movement truck. A very exciting capability. Next slide. also shows this transition period that we're in, because we often think of Cummins as one of the largest, and certainly in North America, largest engine maker, diesel engine maker. But they actually have already signaled their strong interest in producing electric drive lines, using their engines in many cases, but not all, for plug-in hybrids, range extended electrics, and the like. So we're in a period of real dynamic change when it comes to electric drive lines. Linda talked about using electricity and more electrification aboard trucks for idle reduction, which is a great smart strategy. Increasingly, we are also seeing the opportunity and new markets developing for the use of electricity as the main driver of the vehicle. So go to the next slide, just to walk through a quick background of why it's coming and where it's coming. We've been doing an awful lot of work with key agencies, NYSERDA and others, and in California with the Air Resources Board. And in particular there, we're looking with them at understanding how is the market shaping out for advanced technologies like zero emissions or battery electric, fuel cell electric, and what's going to be the sequence, and what are the right investments to be making as public agencies to spur this. And go to the next slide. We're seeing the status of the technology is moving rapidly towards the market in key areas. If you go all the way to the right-hand side of this, you can see transit bus. We've seen battery electric buses really start to launch. There's more than 300 of them across the United States now. Shuttle buses and medium-duty delivery are close on the heels of the transit bus into the marketplace for battery electric. And then farther back, but moving through the development process, and we'll talk about some of these, would be things like cargo drayage, regional heavier trucks, and the like. Next slide. There's really no secret in some ways why we're seeing some of these technologies develop, and that's that battery costs, which are one of the core components in cost in an electric driveline, are dropping much faster than were expected, faster even than the DOE targets, Department of Energy targets. You can see these last data points, these little blue and red dots that you see on the bottom part of the screen were just recently added to further flesh this out. We are starting to see battery prices, though, get down towards $100 per kilowatt hour. The bottom line of that is it can lead to much longer range at much lower cost. Next slide. So one of the things that we have been doing is laying out if you will, the roadmap, starting with what are the beachheads, meaning what are the first markets of success where electric drive can take hold, because the business case makes sense, and then what will be the secondary and third markets that can build off both the technology being transferred to other applications and the business case justifying those other applications. So we've talked about transit bus, and battery electric transit bus has really been the beachhead for the reemergence of electric drive into the medium and heavy duty sector. And then we will talk about some of these other sequences as we go forward. So if we go to the next slide, one of the things that's really been pretty exciting is that there's more than 20 different zero emission bus products now available. We've got 9 different bus makers and upfitters in the marketplace. This is starting to turn into a very dynamic and exciting space. And as I mentioned, we're up over several hundred vehicles nationwide, and those numbers look to really grow. Next slide. We'll show you what's available even just in the Northeast market. These buses are currently listed on the zero emission bus voucher, or the zero emission vehicle voucher program in the state of New York State Truck VIP, and zero emission vehicle VIP, the voucher incentive program. So these vehicles are available, and there's other manufacturers. Nova Bus is actually bringing electric buses into the marketplace. Gillig is bringing electric buses, and there are others. Next slide. So we're starting to see the footprint being cemented, if you will, for these the transit buses. We're starting to see the first shuttles out there, or school buses and others. And the next area that's really starting to show promise and growth is delivery of all types, pickup and delivery, anything from parcel and package up through heavier duty versions of that, and also the off-road yard hostlers or terminal tractors. So Let's go to the next slide and take a look at some of the products that we're starting to see out into the marketplace. There's a number of manufacturers who are now providing either the full vehicle or the core components. You can see some of them here on the screen. There's also First Priority and some other manufacturers. This is a pretty exciting space where we're seeing these products with the battery prices coming down and with high utilization on these return to base centrally fueled fleets. We're starting to see some decent business cases start to pencil out. Next slide. We're also seeing into the medium duty segment. These are examples of vehicles that BYD is offering. BYD is a very aggressive player in the space right now, not just in the bus market, but now into the truck market, which they do build in North America. Those top two trucks are really what you'd see as cab over medium duty delivery trucks in class 5 and 6 size ranges. Down below on the left is actually a class 8 drayage truck. So that's a regional truck, can drive about 100 miles, pulling a cargo container behind it. In fact, a little longer than that. And then on the right-hand bottom is a terminal tractor, so an off-road class 8 tractor for moving cargo around container facilities. These trucks are actually all available that you can go through incentive programs and order right now. Next slide. There are other players as well in the space. Orange EV is one of them, also an available vehicle right now that you can get voucher incentives to put on the road. So in these types of applications, we're starting to see the good early success. And if we go to the next slide, it's an interesting signal of how people do view this emerging market. This is Mitsubishi Fuso's e-Canter truck. We'll be seeing a soft launch of these vehicles later in the year. It's a class 5 zero emission battery electric truck. This is part of the Daimler International family of companies, but Mitsubishi Fuso will be the manufacturer of it. And this is going to be another exciting entrant because we're starting to see now large OEMs moving into the space. Next slide. Daimler has signaled that really over the next 5 years, they intend to really target urban drive cycles, meaning not just within local areas, but within an urban region for the trucks that they're building. Next slide. So we're also building on the backs of a lot of strength that's come out of the hybrid area. Some of the early leaders in hybrids have been folks like BAE Systems that have brought a lot of the most successful hybrid buses into the marketplace, still operating and selling all over America. They're also then building a lot of the core components that eventually also find the use in electric buses and trucks. So it's a really important area to have these parallel markets of hybrid and electric working together because not all solutions fit all fleet duty cycles. So if we go to the next slide, we can get a sense of some of these vehicles that are moving out. Hino's pretty well known with their products. This is a class 5 cab over delivery truck. A lot of sales of these, several thousand in the United States over the last few years. Next slide. A great Northeastern company, XL Hybrids, selling a lot of units in the size range from class 2B up through 5, touching on 6. This actually gets installed rather simply more as a new upfit or as a conversion. We're seeing hundreds of these units and growing being installed. And it's not just hybrid electric. If you go to the next slide, we're also seeing hybrid hydraulic players building kind of the next generation. A number of these units came out many years ago as first generation units. Building on the knowledge gained from that, you see companies like Lightning Hybrid doing similar things to what Excel is doing, but using hydraulic technology for storage rather than batteries for energy storage in their hybrids. Next slide, please. And while some of these things that I've shown you, all of them are in the market, this is an emerging capability, not just to store energy for use in the powertrain, but actually being able to export power out of the vehicle. We've talked about being able to plug in your vehicle overnight for idle reduction. This is a truck that actually uses the power export to power either power poles to be able to keep a customer in service during power outages or during service calls, or for emergency centers during fires. This is something that's actually starting to move out with a couple of West Coast utilities and others testing them now. Next slide. So there are a number of incentive programs around the nation that have really been on the leading edge of making it possible for fleets to reduce their early entry risk for the higher incremental cost. Usually the operational cost of these vehicles does pencil out to be cheaper. Even with low diesel prices, they've shown a real good capability for that. New York has been one of the leaders. Patrick Bolton from NYSERDA will speak next on some of these topics. But there are fairly good incentives. And in fact, we've sold out our incentives for hybrid and natural gas in New York City, but we still do have incentives available for electric trucks and buses in key areas of New York State. And this has been one of the key drivers in California, Chicago, New York, and elsewhere to really move this early market forward and give fleets the confidence to take this new technology and put it into revenue service. Next slide, please. So the next high ground we're heading towards, we've seen the transit buses launching. We're seeing the emergence now into the marketplace of delivery capabilities. And we're seeing the development of product that's really going to move into this, you know, you see a lot of interesting terms on the screen, but extended range, medium and heavy duty delivery. Think of this as a Chevy Volt for a truck, meaning that it can drive on zero emissions mode, but then has some type of a fuel cell or an engine on board that can give it extended range. A real key technology for heavy duty, like a Class 8 truck in a regional environment. So if you look at the next slide, it's exciting what is going on in this space, and we'd really love to see some of these demonstrations take place now in the Northeast. We think it's ripe for it around terminals and ports and other areas. But on California, the 5 ports, 4 different truck manufacturers are involved in a demonstration that hopefully will soon lead to, by 2019, a pilot project and then commercial production of range extended or plug-in or just long-range battery electric trucks, but serving as Class 8 cargo movement trucks within a large urban region. This is a true new capability that is moving down the commercialization path right now. Next slide. So quick summary, you know, whether you've seen it in your applications or not, there are these technologies and products now emerging into the market. They are available in the Northeast, and they are particularly good, as I said, right now. The best duty cycle and the products available will be more urban region focused, pickup and delivery, and other return to base duty cycles. The vehicle choice is expanding, and it is moving into heavier and longer range platforms. The market is moving through some clear market stages that I think all public agencies can really do themselves a favor to understand and see how to support to really move the technology steadily through this pipeline of commercialization. And I would add that I think faster growth would definitely come from taking the model that we've seen in Chicago and New York and elsewhere on these voucher incentive projects and taking them into other supportive regions along the corridor structure of the Northeast. State funds, CMAQ funds, VW funds could all be possible funding sources for these streamlined point of purchase vouchers that are very helpful for fleets, because what they do is take the price, some of the price of the incremental cost directly off the top of the invoice and let the fleets pay less right at the point of purchase. So the question, I think, for folks on the call, and it'd be great to discuss later, is how can you lead this charge? Whether it's to use these vehicles in your fleets, encourage others to use them, or set up support structures to help continue to move these capabilities quickly through the commercialization process. So that's it, Alicia. Happy to take part in discussions as we get to that.
Great, Bill. Wonderful presentation. Extremely informative, and it's great. We do have a number of manufacturers that are providing these very innovative, cool technologies on the phone with us today. Just to name a number, BAE Systems, XL Hybrid, Mitsubishi Fuso, BYD Motors, First Priority, Thor trucks and Cummins are all on the line today with us, so perhaps they can engage in a discussion. We also have a number of SmartWay partners, our shippers and carriers that are also on the phone that are active and looking at how they can reduce their environmental footprint. And so we're really pleased that we have good participation today, and hopefully, Bill, we can ask some good questions at the end of our discussion to help engage these partners. So thanks again for your excellent presentation. All right, next I would like to introduce Patrick Bolton, who is the Senior Project Manager with the New York State Energy Research and Development Authority's Clean Energy Research, Market Development and Transportation Program. He is responsible for developing and managing clean transportation programs related to alternative fuel vehicles, deployment and refueling, vehicle electrification and infrastructure, diesel emission reduction technologies, biofuel distribution, and maritime-related research and development projects. Patrick is a graduate from the Virginia Military Institute with a Bachelor of Science in Mechanical Engineering. Patrick also is the project director for the New York Truck Voucher Incentive Program, and he'll be speaking about a number of other initiatives that he's responsible for deploying and demonstrating electric truck technology and helping the state grow its infrastructure for electric vehicles. So Patrick, I hand it over to you.
Great, thank you, Alicia. For those unfamiliar with us, NYSERDA essentially acts as the Department of Energy for New York State. We oversee many programs related to energy, from research and development to demonstration, and including the deployment of new technologies that reduce energy use and pollution. So in the Clean Transportation Program that I work in, we have three main focus areas: electrified vehicles, mass transit, and transportation efficiency, which includes freight. What I'd like to talk about today is a little bit about what we are doing and have done related to freight and alternative fuels, including electrification of vehicles. Okay, go ahead, next slide. Oh, there we go. It takes a little bit. All right, so one of the things that we do are planning studies. So the study that I'm showing here related to looking into how to move more freight through New York's marine corridor, which goes from the Great Lakes, then through central New York to Albany, and then from Albany down to New York City on the Hudson River, utilizing the canal system. So this study, again, was looking at various types of products that could be moved through the canal system rather than through trucking or other means from the Midwest to New York City. Go ahead, next slide. And one of the things that came out of that study was, how can we actually make the canal system even cleaner as we're moving those goods? So NYSERDA worked with several different companies to develop and demonstrate an electric tender. The tenders are the vessels on the canal system that maintain the canal and assist the tugboats. And we were also exploring the development of an electric tug that actually moves the barges on the canal system. Next slide. So one of the other things that we do are education and technology transfer, such as this study that we're showing, the last mile freight delivery study. This study was looking at using various types of alternative fuels, including vehicle electrification, for delivering goods from depots within a city to the actual delivery points. And that included light-duty electric vehicles as well as even electric trikes that we can see there. Next slide. So this study led to an even deeper study that was looking at policy research and feasibility. So we were looking at how do we actually develop what we call green loading zones. So green loading zones would be places where alternative fuel or clean fuel trucks, like electrified trucks, could park in the city and recharge at the same time while delivering their goods. And it would be looking at essentially zero emission last mile freight delivery with trucks as well. So go ahead, next slide. So NYSERDA, again, we also do product development and demonstrations. Some of the work that we're doing in that area currently is we are working with a major fleet and some technology development companies to develop a short range electric delivery truck What we found is that, especially in heavy urban areas like New York City, you don't necessarily need a truck that can go 100 or 125 miles on a charge, because in the city, a driving cycle might only be 10 to 20 miles per day. So we were looking at developing that. We're looking at developing an anti-idling technology, which would provide shore power essentially for ambulances. In New York City, the ambulances are staged around the city, so they have faster response times. So they don't leave from an ambulance depot; they leave from a spot where they park on the street. So this technology is looking at providing power to keep the medicines on the ambulances cool and provide shore power and hotel loads for the ambulances so they don't have to idle their diesel engines. One of the interesting parts of that technology is that technology could also be used for the green loading zones to provide power for refrigeration units on refrigeration trucks that are located in green loading zones. We're also developing battery systems for reducing demand charges for the DC fast chargers. As I think most people would agree, the current model of utilizing DC fast chargers, especially when utilization is initially low, there really isn't a model for showing that you can actually make money if you still have to pay demand charges. So we are looking at battery systems to reduce the demand charges and hopefully make the DC fast charging more profitable. The fast chargers are something that we're going to need if we have interstate traveling trucks traveling. So we will need to have DC fast chargers that can charge these trucks very quickly. We're developing a high efficiency switch reluctance motor for electric trucks. The advantage of the switch reluctance motor is that it doesn't have a permanent magnet and does not need to use the heavy earth elements, and could also be more efficient than a permanent magnet motor, which would increase range and make the electric trucks be able to drive farther as well. So another technology we've been looking at is anti-idling for locomotives. This is mainly work that we've been doing with regional railroads, where they don't typically operate during the winter, at least very little, but they have to operate the engine for the entire winter. So they'll turn the engine on and they'll idle that engine for 4 or 5 months during the winter time to ensure that the engine will not freeze and destroy the engine itself. So we've been looking at installing anti-idling devices on locomotives so they don't have to idle the entire engine. Next slide. So on our vehicle deployment side, we operate in partnership with CALSTART, New York State DOT, and New York City DOT. Our truck voucher incentive program, as Bill had said earlier, this program provides incentives at the point of sale so that the customer that is purchasing the vehicles do not have to actually finance the amount of the incentive. The price of the truck is reduced at the point of sale by 100% of the incentive amount that we give. To date, we've provided incentives for almost 600 trucks, which include battery electric, hybrid electric, compressed natural gas, and also diesel retrofit equipment, such as diesel particulate filters. And the incentives under that program, as Bill said, range up to $150,000 per truck for the full battery electric Class 8 trucks. Next slide. So this slide is just giving us a little flavor for some of the things that we're looking at and potential activities for the VW settlement monies. These are not set in stone yet. These are just ideas that we're exploring. So we're looking at obviously providing level 2 charging stations and DC fast charge along freight corridors within New York State. We're looking at providing incentives for electric and other alternative fuel trucks and buses as an expansion on our existing truck voucher incentive program. We're looking at new diesel truck and bus replacements, retiring older diesel buses and trucks and replacing those with newer, cleaner diesel trucks and buses. We're looking at electrified clean port equipment and drayage trucks, both for ports and for freight terminals as well. Looking at electrified ground support equipment and also electric railroad freight switchers. Next slide. So this isn't electrification, but I wanted to throw it out there anyway because I think it did play an important part in assisting the Northeast in being designated for the natural gas clean fuel corridors. But NYSERDA has been working for years to develop compressed natural gas refueling stations along the major freight corridors within New York State to allow both intrastate and interstate trucks to pass through New York or drive through New York and be able to refuel within the state without having to worry about running out of compressed natural gas. The approach and the methodology that we'd be taking going forward with the electrification side is similar to what we've done already on the natural gas side. Next slide. And also on the electric infrastructure, where we stand to date, NYSERDA has already paid for the installation of over 700 charging stations around the state. We're currently collecting usage data that's published on our website. New York State has a tax credit of 50% up to $5,000 per installation. That is essentially per charger. So if a company wanted to install, 50 chargers at a truck stop somewhere, they could get 50% up to $5,000 for each of the 50 installations. We are also working with CALSTART and some other partners on we call our Cleaner, Greener Communities projects. These projects are outreach and electric vehicle related to also install up to an additional 200 stations around the state. And we have an additional program that they'll be coming out hopefully in the fall. We're calling our Purchasing Collaborative that will be providing additional charging stations around the state with targeted incentives primarily for workplace, fleet, municipal, and multi-dwelling unit areas. Next slide. And that's it for me. Thank you.
Great. Thank you so much, Patrick. Wonderful presentation overview. All right, now we turn our attention to John Shipman with Con Edison. And John his role for today's call is to bring the perspective as it relates to a utility and the role that a utility plays in helping us to promote transportation electrification and what that means for building out our infrastructure to accommodate light duty, medium duty, and heavy duty electric vehicles. So let me just provide a little overview about John Shipman. He oversees Con Edison's demand management, customer engagement, and electric vehicle programs within the Distributed Resources Integration Organization. His background includes time as Con Edison's chief automotive engineer. He was also the department manager of secondary systems analyses and the manager of gas management development. John combines a mechanical engineering degree with a graduate work with energy management. In his current role, John is responsible for developing business opportunities around transportation electrification. John, I turn it over to you.
Well, thank you, Alicia. And good afternoon to everybody on the call. Could you just go to the next slide, Alicia? So here's what I plan on covering, just the current EV landscape, how we see things growing, what other utilities have done in this space over the recent past, the impact of what New York State calls non-wires alternatives under the Reforming the Energy Vision, our activities for demonstration projects under the REV framework, and what we see as the way forward and opportunities to test and learn on new business models and technologies. Next slide, please. So if you just look at what's happening over time, the types of vehicles, particularly in the light duty space, I think Bill made this point very clear that there's a lot of product available and it just keeps expanding over time. And with announcements and developments, we're really getting to the point where we have product available in all categories. So number of years back, I think people were questioning whether or not EVs were going to happen. EVs are happening. The question is, how fast are they going to happen at this point in time? Next slide. And if you look at the range on vehicles, that too has been advancing over time and continues to do so. We started out with relatively low all-electric range, and we're moving up into the couple 100 miles to 300-mile range with product announcements and actual products on the street today. Next slide. If you look across the country at investments utilities have made in this space, there are combined 12 utilities with a total investment of about $260 million that are in progress as we speak, things being built out. There's another 11 utilities with investments that are proposed for $1.5 billion. Only 2 utilities have actually withdrawn their proposed investments, and that was for a total of about $19 million. So the trend is upward. Utilities want to get into the space, and there are different approaches and different models out there, from utility ownership all the way up through and including chargers. In a case like San Diego Gas and Electric, that's the case. They have a unique situation where their renewable penetration has created peaks in the middle of the day, and so owning and managing charging to address that renewable situation is important for them. Many utilities have taken what they call a make-ready approach, where traditionally the utility will pay for infrastructure up to the property line with maybe a 100-foot setback into the property line, and then the property owner takes over the electrical wiring from there. The make-ready approach is a model where the utility would actually do all the wiring up to the foundation and penetrations, what they call the stub, and then the property owner would just have to install the actual charger in that space. And then there are approaches that cross the borders with rebates for chargers, with shared costs on either end. Next slide. In New York specifically, we have REV and we have NWA, and REV is the New York State Reforming the Energy Vision, which is a forward-looking approach to restructure the electric utility industry to advance the penetration of distributed energy resources and to kind of remodel the way we do business, rather than looking at increasing load and then building out area station, substation capabilities. We're looking for alternatives that will allow us to reduce the load in those areas at lower costs by the either energy efficiency methodologies or by the implementation of distributed energy resources that can inject back into the grid when needed. The main focus there is to come up with those non-wires alternatives, not the traditional method of building out more wiring. So the prior slide I talked about make-ready approaches and things like that. A non-wires alternative is not really very consistent with that kind of thinking, unless you expand the scope of the way you look at the project and the problems that you're trying to solve, and recognize that in order to get to some of the greenhouse gas reduction targets set in the state, we will need transportation electrification, because the contribution from the mobile sources is large enough that we have to have them in the portfolio. So while we try to think about what kind of infrastructure makes sense and what should be built out, we have to balance those objectives as required. And the real thing here is for us to focus on managing the load while driving adoption. Our regulators have called transportation electrification good kilowatt hours, as opposed to inefficient building systems, which are bad kilowatt hours. So we try to drive out the bad kilowatt hours through energy efficiency programs, but we try to drive up the kilowatt hours consumed by EVs. One example of a program we have in play right now is a Smart Charge New York program, where we manage the peak load contribution in the summertime from each electric vehicle by monitoring their charging behavior and their location to ensure that they're in our service territory. And then we provide rewards to customers that avoid the peak periods from 2 to 6 p.m. in the summer periods from June through September. So we focus on the options for demand mitigation, on generating good kilowatt hours, and managing the new EV load with existing infrastructure in play. Next slide. We've got REV demonstration opportunities in New York State, which allow us to try to drive new business models that can potentially be funded by a broad coalition of stakeholders to see if we can scale those business opportunities as we transition the industry into kind of this non-wires and distributed energy resource approach. So we recently put out a request for proposals that focus on a portfolio approach in 6 areas. Those 6 areas included smart home charging, because studies show that about 80% of the charging on light-duty EVs will take place at home. Much like, even if you think about a medium and heavy-duty, a lot of that charging would take place back at the depot or wherever the main barn is, if it's a transit facility, a bus barn. And so you've got long dwell times there. You have the ability to manage the load because you can determine what your departure time has to be, what time you plugged in the morning, when you got back to the yard, and then you can flow the power to the vehicle to the lowest possible rate in order to meet the full charge that's required there. We're also focused on curbside charging. New York City is very vertical and very dense urban area. A lot of people live in multi-unit dwellings, but those multi-unit dwellings are not the same as in San Diego, let's say, where they're much more vertical in nature. Ours are, much more horizontal in nature. Ours are much more vertical and very dense. And so a lot of people in New York park on the curb because they do not have a driveway. They do not have a place to put their vehicle other than on the curbside. So there is a need for infrastructure there. That curbside charging could also be coordinated with green loading zones, like you saw from Pat's presentation. And then we're focused on the transit bus. There's a lot of energy consumed by transit buses. They are part of the infrastructure that moves people around the city, and they're a key element. In New York, we tend to say that the best electric vehicle is the subway system, which moves millions and millions of people every day via electricity. But we still have cars, we still have buses at street level. So we're focused on electrifying transit buses. We're working with our Metropolitan Transportation Authority to do a 10-bus pilot that will run 5 buses out of Brooklyn Borough and 5 buses in Manhattan. And the plan is to demonstrate in-depot charging as well as en-route charging. And with the en-route charging, you have the ability to diversify your loading in your electrical networks, because you can size batteries so that you can pass by a charger, and any network that's heavily loaded could be relieved from that charging load under summer constraints. We're also focused on school bus electrification. That's an area where most of those assets sit idle in the summertime, and that's when we have our highest peak loads. And if we can develop a value proposition that provides energy back into the grid from that bus in the summertime when we need it, there could be a good opportunity to have clean transportation for students, as well as derive more value from that asset. Additionally, we're looking at fast charging hubs. We've heard from a lot of the infrastructure providers that real estate in New York City is really hard to come by. We've focused on some holdings that we have to see if we can make some of those properties available under this REV demonstration projects. And our thought is that if we have multiple fast chargers at several sites around the city that are close to corridors, that we could have support systems in place for delivery of materials, as well as for individuals who reside in those multi-unit dwellings or are traversing the territory. And the final area that we're focused on was a proactive system planning and design that would allow us to think about things like hosting capacity for distributed energy resources, the specific locational value associated where those distributed energy resources are sited. And if that model is turned on its head, so to speak, that becomes an area where you can actually encourage people to put in the EVs, because the same electrical infrastructure would be at play. Next slide. So when we think about these things, most of this I think I covered already, so I'm just going to bounce to the next slide. I think where we really are at today is that we don't have all the answers. Nobody has all the answers. If you look at what's going on in California, they have very unique, different models of build out for EV infrastructure, and I think that was done on purpose. Their Public Service Commission was looking to test different models, and when I talked to the folks out there who are in charge of developing these things, they all readily admit that they don't have all the answers either, and everyone is flexible enough to shift to what works the best, but we have to put some energy and time into the process in order to determine what turns out to be the best approach. And as part of that, I think it's important to expand the stakeholder engagement so that you get input from all sides of the value chain, so that we're just not optimizing one spot. We plan to learn from these demonstration projects that we have ongoing and modify and adjust as we go to ensure that the learnings are used to help inform future offerings and business models. Next slide. I think that's all I had. I think the next slide is a thank you. So with that, Alicia, I'll turn it over to you.
Alicia, I guess this slide isn't advancing. Could be something happened to Alicia's telephone hookup. Yeah. So I'll just step in. This is Abby. Thank you so much. That was really, really educational. As usual, we're kind of getting a little bit pinched for time, but we do have some stored up questions for various presenters. So I would like to, there we go. First, do justice to those questions that are pent up, and I want to make it clear that the discussion that we don't manage to get to today, we can take up on our August 24th webinar, which is more place focused, just by the way we've kind of carved it out than the webinars we've had so far in 2017. So if we don't get to some of these delicious discussion questions today, we will take them up next time. And I hope really everyone who's not on vacation can join us for that next webinar. So let me just quickly read out some of these questions. Lee Granis asked, how many of the high utilization electrified parking space sites are located where there's adequate enforcement of laws that govern idle reduction, thereby, I guess, incentivizing people to actually use those spots and use them properly. I guess this would be a question for Linda. Do you have a sense of that?
That's actually sort of an interesting question, because I don't think there's much enforcement anywhere except California, and I think there's one or two Northeast states where idling is part of the SIP, and so that's enforced. But the high utilization spots are mostly in Texas, and I don't know of any enforcement in Texas at all. So I'm not sure there's a correlation. You'd think there would be.
And to my experience here in the Northeast, the state agencies and also the feds are reluctant to enforce where, as you say, the truck drivers are taking their federally mandated rests. So that is a problem with the enforcement approach.
Well, enforcement is also expensive. There's very little enforcement nationwide. And you can, to some extent, you can understand it. If there's a limited number of police, do you want them to be going after criminals or truck drivers that are trying to sleep?
Yes, and there is a shortage of state air agency staff to also do that enforcement.
Yeah.
We have a question from Abby Blessing, not me, but a different Abby, who said she recently spoke with an air quality specialist and was told that though diesel auxiliary heaters use less fuel, their emissions profiles can be much worse than just running the main engine because there's no emission requirement for the equipment. Can you speak to this? Setting aside the fuel and price savings, how can we be sure these devices improve and not worsen air quality? Do you want to take that, Linda, or shall I?
Yep, and in fact, we published a paper at TRB, I think 2 years ago, which says just that. The new trucks, only the very new trucks, have such stringent PM and NOx requirements that they do, in fact, have very low emissions at idle. They're still emitting CO2 and using lots of fuel, but the auxiliary power units, the small diesels, do have air quality, do have emission requirements, but they're much less stringent. And so the PM and the NOx from an APU can be higher than on new trucks. So,
on a gallon per hour basis, right? So what's the comparison?
Well, not on
multiplier.
On a per hour basis.
Right.
Yeah.
Right. So if you have a choice between idling your main engine in a new truck and turning on your new diesel-fired heater, the
diesel-fired heater is very low. It's the diesel APUs that are the potential problem, but it's still way lower than a diesel, than an older truck would have.
Okay. Great. I think that'll do us for now. We can follow up more later on that question. Let's see. We have a question that is aimed at Alicia, but perhaps for Bill instead. I work at an engineering R&D company for Argonne. Oh, he's saying for Argonne and CALSTART, what are some specific technologies that need to be developed in the near term to reach business model objectives? What's inhibiting tech transition?
Right now, there are a variety of things, and it really, as with all new technologies, a lot of it is very duty cycle dependent. And I think right now we need to build up the supply chain base to get more competition into that space. And it's partly what's happening with this transition from bus to medium duty delivery and shuttle buses, school buses, and then into heavier delivery. As we see prices come down from engineering improvements, from the drop in energy storage and the like, that's what's taking us through this first stage. I think the later stages that I was alluding to, for instance, a Class 8 tractor serving a pretty heavy duty cycle around a region carrying cargo, that's where we need these range extender technologies. And that can mean things like small fuel cells, and we're starting to see these coming out of, believe it or not, the industrial forklift market, which has been a real good beachhead for fuel cells, smaller fuel cells. They happen to be about the right size to run as a range extender or just a small device to provide additional electricity to extend the range, or very clean, small engines. So we're really actually very excited about the low NOx natural gas engines coming out, and getting those set up as engine generators for a range extended electric drive is another really interesting breakthrough area. So I would say those are a couple of the areas, and then frankly just certification of of hybrid, as we get into engines that are doing a different job than they were originally intended for, meaning they're not necessarily always powering the full vehicle, but part of a total powertrain system. Cummins has really been on the leading edge of doing this. That's another area, really integrating a whole advanced powertrain that includes electrification. That's one of the other high grounds that I think we need a lot of work in.
Great, that's a great answer. Let me just mention to Alicia that some folks are still having trouble downloading the first handout, the slides from today's webinar. I had some success, but I think some people are having trouble. So if there's a way to reload them at the last minute here, please do. But otherwise, you can visit the Northeast Diesel Collaborative website, and all our slides from past webinars are lodged there, as well as complete recordings. So just check that site in several days, and you'll find them there, even if you can't get them today. There's a question for Patrick. Is NYSERDA implementing the use of certified green transportation bonds for low carbon projects?
Not currently. I think that is something that has been or is being looked at, but not currently, no.
Okay, great. That's straightforward. And this is for John. Will the planned Port Authority New York, New Jersey bus depot upgrade at 42 at 42nd Street be e-bus friendly?
Well, I know that one of the routes that we're working with the MTA on is the 42nd Street route, and so we're installing some in-depot chargers at the Michael Quill depot there. If that's the same thing that's being referenced, then I would say yes.
Sounds good to me. All right, and we have one that I'll skip back to from the West Coast, which is asking NYSERDA in general about what kind of locomotive idle reduction technologies you've piloted and which railroads were involved. I think today you were focused on the new technology you're developing, which is for long non-working periods during the winter by regional railroads. But do you want to just briefly mention the other technologies you've dabbled with or demonstrated?
Currently, the ones that we've done so far are all with regional railroads, so they're not like the CSXs. They're the ones that might have, you know, a couple hundred miles of track that they do essentially like the last mile delivery of rail goods. And with those projects, they've all been fuel-fired heaters. So they use the onboard fuel from the locomotive to turn off the main engine and just heat the coolant with the fuel-fired heaters. We've been looking at different types of electrification strategies, but the regional railroads tend not to be near high-power electric sources, at least in New York. So we haven't progressed too far on that side yet. So again, the fuel-fired heaters is primarily what we've been looking at. And we're also looking at electric freight switchers as well, so going forward.
Great, that is a great response. So looking at our remaining time, Alicia, we have 4 minutes, I think. Do you want to post any of our discussion questions? And I'll voice them. So this first set of questions is about charging facilities for electric and hybrid trucks as opposed to idle reduction facilities. And I'm trying to get us thinking specifically about the Northeast. Where are those facilities needed to support any comer, anybody who wants to use them? Where do we need them for private or limited access use? And then which specific types of facilities just seem to be the lowest hanging fruit? I think we've talked about ports. We've talked in general about clusters of warehouses. but can folks on the phone think of any particular corridors with nodes like this and usage demands like this that we should really be focusing on as a collaborative? I'll open that up to any of our presenters.
Yeah, this is Bill. Just an initial thought. Certainly, I mean, what we've seen with the beginning uptake for instance, zero-emission yard hostlers or terminal tractors means that you will probably need to have, obviously, recharging facilities at those kinds of facilities anyway. Intermodal yards, these terminals, distribution centers. Those could be interesting nodes for delivery trucks to also then plug into to extend their range. We're seeing this done in the bus marketplace where you have range extender charging on route charging. And so these could be places where you might start to look at whether to cluster some charging inside the fence and outside the fence. That's one approach. I think we've been looking, because it's still maybe too early for fast charge, if you will, truck charging along the major interstates per se, but any place that you have put in the facilities, for instance, for overnight charging, you could have the capability of doing some charging to extend a delivery truck's range using the highways. And then the last piece is we're really looking at building out a network of opportunity or route charging within urban regions that support these corridors. And this network of charging could build on the back of some of the fast charge being put in for light duty passenger cars. And you could designate in key areas where you look at the route structures of a number of distribution trucks and say, wow, within this region, we could use 5 fast chargers for distribution trucks that also could work for light duty passenger cars. And that's what we need to start looking at. I think it's still early, but it's the right time. And I was really pleased to see what Con Edison's doing in terms of kind of this planning. How can we protect the grid and also put some of this charging out in the right places that this model unveils itself?
Great. Those are great thoughts. Any other thoughts from the presenters on that set of questions? All right, let's go to the second.
All right.
Oh,
go ahead. I was just going to say
go.
that I kind of echo Bill's thoughts in terms of, you know, where you are close to major highways and you can put in a fast charge hub that can act as a location where, you know, long haul or regional delivery trucks can pull in, as well as passenger cars that are en route to someplace else. That seems to me to be the place where we want to site these things.
Excellent. That sounds brilliant. It's hard to imagine what that looks like. Is there an example out there in the world of that having been built yet, or will we be the first?
Someone's got to be the first.
And we're the powerhouse of the nation, right?
Well, and Abby, this is happening in real time. So I do think that particularly in these dense urban regions, we really have an opportunity to co-use our infrastructure that we might be putting out for light duty and make sure we just size the access to it appropriately for medium duty vehicles as well as the charging rates. And that would be a great demonstration project for the Northeast.
That sounds exciting, truly exciting. All right. Alicia, did you skip over part 2? I think we have only got half a minute left. I just wanted to show people part 2 of our discussion questions because I think there is a fair amount of interest in the Northeast, at least among the environmental agencies in idle reduction. So, you know, because we don't have really time to actually discuss, we'll bring this over to the August webinar mainly, but I just want to get you all thinking about you know, what are the incentives for getting past these barriers that Linda so eloquently outlined with utilization? Is there no answer other than enforcement and regulation, or is there a way to, you know, that states and MPOs can incentivize better utilization of no idle spaces that perhaps are installed where additional truck parking is needed anyway? And then we've heard in the Northeast from some experts that really reefer idle reduction is the way to go in our market. And so we should be thinking about where specifically are the facilities and who are the shippers and carriers with whom this could work. All right, Alicia, to the last discussion slide. There we go. And so we should also be thinking about, what kind of incentive programs could we construct that, are, building on the experience of like the New York VIP program and other models to really jumpstart the spread of these technologies, and what new models of collaboration could we manage in our snug little part of the country that might provide another example for the country. And then the last slide. There we go. I think we've touched on this already, Bill. We're talking about how can we combine truck and passenger vehicle charging, and then thanks to Patrick, we've also talked about multimodal charging. So these are things to keep in mind as we move forward. All right, I'll hand it back to you, Alicia, to button us up, and then we'll let people go.
Great, thank you, Abby. Well, wonderful job, and much thanks to all of our panelists today. And Abby, thanks for taking over there. I had a little bit of a technical malfunction there with my phone. But anyway, thanks so much, everyone, for taking part in our call today. I think it was an excellent discussion. And unfortunately, we can carry this conversation, a number of the good questions that Abby identified, to our next webinar. So it's actually a perfect tee-up. So I just wanted to put the reminder out there that we do have our Save the Date out for the Northeast Diesel Collaborative Partners meeting. Sure to be a really good one, as they all are, and we would love to see you and want you to be a part of the discussion on how we move our region forward to promote clean transportation and clean corridors. Again, our next webinar will be on August 24th from 2 o'clock to 3:30. You will be receiving information from me on the details of that webinar, so we look forward to your participation there. If you have any questions or want to reach out to any of these strategic planning partners, I have our contact information here. It's also on the attachment. I understand a number of folks had challenges with downloading this attachment. It was a pretty big file, so that might be a part of that challenge. We'll make sure that you all have access to it. We'll be putting it up on our website so that you can download it at your leisure. And we will also be providing a recording of this webinar in case you want to share it with your partners. But again, thank you so much for joining us, everyone. Again, thanks to our panelists for all your time. It's a great contribution to the discussion today. And we look forward to seeing you on our next webinar. Thanks so much and have a wonderful day.
Bye, guys.
Bye. Thank you so much.